Hey everyone, welcome back. This is grade 6, unit 5, lesson 10. Now we've been focusing on algebraic expressions 1 through 9, using the distributive property and using the order of operations, lots of things that are fairly new to us. Lesson 10 actually takes us back to ratios, which we learned about in the beginning of the year. So lesson 10, we're going to be thinking about ratios. Now, we're going to take them a step further than we did in the beginning of the year, but it's going to feel like we've stepped a little bit away what we were doing at the beginning of the unit. Remember, ratios talk about a relationship. The relationship between amounts or the values, we call the values of two things, or it could be more than two things. It actually could be multiple things. But it's the relationship between the two amounts and how if one amount of something changes, then the other amount of something also changes. An example, the amount of sugar that we use compared to the amount of flour we use if we're making chocolate chip cookie dough. Yum. So, if you haven't gotten a chance to watch any of our cooking videos that have to do with ratios, I would encourage you to go and do that if you have some extra time, because cooking is an awesome way to think about ratios. Because if I make 2 batches of chocolate chip cookie dough, I can't put in just twice as much sugar and not twice as much flour, or the cookies won't turn out. So instead, I have to increase the amount of sugar at the same rate as I do the amount of flour. And remember, we said it could be more than two things. I'm going to add in a 2 plus. It could be 2 plus things, because if I'm making a second batch or a third batch of chocolate chip cookie dough, I also have to add in more chocolate chips. I have to add in more salt. I have to add in more baking soda. So if you do any cooking or baking at all with your family or by yourself, you know that when you make 2 batches, you have to increase everything. You can't just choose some things. So that's the essence of ratios, the fact that there are two things changing at the same time. So that's what lesson 10 reminds us about. Okay, I'm on page 253, and page 253 helps us think about number lines. We're super familiar with seeing just a regular number line. We see it all the time. We see it on the wall of school. We use it constantly. But they're introducing us to the idea that you could use two number lines at the same time, and they're different number lines, and that's tricky. So when you look at what's in the picture they show in your book, it might look different and confusing, and you might say, that doesn't look like any number line I've ever used. And the reason is because they're using two different number lines at the same time, and they're showing how they intersect with each other. So the first number line there is talking about when you go to the store, to the deli, to the grocery store, and you buy something out of the deli case, like potato salad. So if you've ever eaten potato salad, you know it's made out of cooked potatoes. It sometimes has eggs in it, sometimes has celery or onion, and it has a mayo and mustard kind of sauce on it. So they're talking about buying potato salad from the deli. Well, how do you know how much it's going to cost? There's a sign that says somewhere, kind of probably it sticks up uh, out of the tub that they have back there of potato salad, and it tells you how much it is. It's labeled somewhere so people know how much it costs. Well, in this particular case, they're telling us that 1 pound, no, I'm sorry, 1/4 pound of potato salad costs $1. So their sign would say 1/4 pound equals $1. Or they might actually tell us differently. Sometimes they'll label it per pound. So sometimes they'll say $1, or instead of $1, it would be $4, and they'll write a little sign like that, a little slash, per pound. So their sign would say $4 a pound. So how do you know how much you're going to pay? Depends on how much you buy. If you're having a big old picnic with a lot of family or friends coming over, you probably need a lot of potato salad. If you're just buying some for your family for supper one night, you might buy less. In fact, you probably would buy less. So the number line up on top is the pounds of potato salad that you could buy. So I'm going to label up here pounds of potato salad. Now let's look at the next number line. Okay, so I've added the second number line. Notice I've added it in a different color. I think that really helps us see that this is a double number line, but it really just is two number lines put together to see how they intersect. So in our book, there's a big line that goes straight down right there. And the reason is because you can't really buy less than any potato salad. So we know that number lines actually continue to the negative side, and many of us have been experimenting either subtracting by going negative, or we've been working with negative numbers. And that's exciting, but when you're talking about a number line for things you're buying, you can't buy less than 0 potato salad. That doesn't make sense. So our book puts a line here to tell us that's where we got to stop. So it tells us if we buy 0 potato salad, this is, hold on. Holy cow, I labeled it wrong. Oh my goodness. Let me be right back. Sorry about that. So I hope when you saw me labeling that as the pounds, I hope you were thinking to yourself, wait a minute, isn't that the cost? And you were right. The cost in dollars is this number line. The pounds of potato salad is this number line. So sorry about that. If it's $4 per pound, this is the dollars, and this is the pounds of potato salad. So how we interpret this double number line is we look at what matches up and down to each other. Or we could write it actually differently, but we're going to match it up and down here. So the cost in dollars. So if you go to the deli and you order 1/4 of a pound, it's going to cost you $1. If you order a half a pound, it will cost you $2. If you order 3/4 of a pound, 3/4 of a pound, it'll cost you $3. And if you order 1 full pound of potato salad, it'll cost you $4. Could you keep going? Well, sure. Remember we talked about if you have a big family gathering or a lot of friends coming over, maybe you need more. Maybe you need a 1 1/4 pounds of potato salad for $5. We could keep going. You might actually buy 2 or 3 pounds of potato salad if you want a lot for some activity that you're doing. So double number lines just show the information going along for two different things at the same time. And you'll notice that both numbers are changing. The more you buy, the higher the cost. The less you buy, the lower the cost. So they're varying at the same rate. That's what makes them ratios. They're changing at the same rate as each other. Now, this might be somewhat familiar for you from our previous learning, and I hope it's feeling at least a little familiar. The next part is we're going to start using variables, putting letters in like we've been. This is how it connects to the rest of our unit, lessons 1 through 9, is we're going to start putting letters on this, what we have going on here to see if we can find some variables that make sense, and if we can make any predictions about things or change numbers like we've been doing the rest of the unit. So what would be a good letter for us to use for the cost of the potato salad? Well, you can choose anything you want, remember? I would either choose a C for the cost or D for dollars. And it totally doesn't matter what you choose. It's just something that makes sense. So I'm going to call this C. I'm going to call it C, the cost. Now, what about the pounds of potato salad? What variable should we use to represent that? Doesn't matter, but I would make it make something that makes sense. So since it's potato salad, I'm going to choose P for the amount of potato salad. Okay, the question number 3 on page 253 says, what is wrong with the following definitions of P? Let P be the potato salad someone buys. Well, you can't have it just be the potato salad because we don't know how much people bought. There's they could buy any amount. So that can't be right. P can't be just the potato salad. It has to be the amount of potato salad in pounds. And the next one says, let P be the weight of the potato salad a person buys. And so um, P could be the weight the person buys, but it can't be the same as something else. So it's got to make sure that P is something different than the cost. So the weight of how much potato salad they buy and the cost, and they have to be two different variables because they're representing different amounts. And I guess I should add to that, you need to tell us what the weight is, the weight in pounds. So we have to make sure that we can't just say the weight, but the weight in pounds, because we could weigh it in something else. Okay, we're on page 254 now, and page 254 is helping us think about buying gas. Now, the weird times that we're living in right now, gas is cheaper than any time I can remember it since I was a kid. But I put the gas sign at a more typical, we typically see like $2.75 or something. I think actually right now, the last time I saw it was like $1.35, which is crazy. Okay, so the person, and this is something that you all know tons about because you're with your family quite often when you stop and get gas. So you pull into the gas station. Most gas stations have big signs that advertise the cost of their gas. And the reason they do that is because if you've noticed, if you drive from place to place or station to station, sometimes the cost is different. And so they're trying to get you to come to their station by telling you what the price of their gas is. So in this case, we're saying you pull in and it's $2.75, and I wrote unleaded. Some vehicles use different. They might use diesel or something else, but we're just going to think about if you use regular unleaded. So here you are, you pull up in your vehicle, you pull up to the gas pump, and you're going to start pumping gas. Now, in our book, it tells us that at a filling station, that's a very old-fashioned word for a gas station. So at a filling station, a gasoline, that's the long word, in case you didn't know, the short word is gas, the long word is gasoline. So at a filling station, a gasoline pump fills the fuel tank of a car. Fuel tank is another word for gas tank. So it fuels the tank at a rate of 1 pint per second. That's how fast the gas comes out of the pump and goes in to your car's gas tank. 1 pint per second. Now, if you've ever pumped gas, helped your family pump gas, or at least watch your family pump gas, you put the gas pump in, and you squeeze the handle, and then the gas starts going into the tank. And it actually has an automatic shutoff. So usually you just leave it like that until it pops open and then you take it out. But if you haven't done that, you might not know that. But the more you squeeze, like the harder you squeeze, the faster it comes out. And you can actually hear that. You can hear it like if it's just on the kind of shallow, it kind of makes a lower sound. And if you squeeze it harder, it comes out faster. So this tells us that it comes out at 1 pint per second. Now, do you always buy the same amount of gas? Well, I hope you said no. That doesn't even make sense, right? Sometimes you might fill up if you have half a tank. Sometimes you might fill up if your tank is empty. Sometimes you might fill up if that tank is like on that little red. You might wait until it's like already down in the red. So each time you might put something different. Sometimes you might say, well, I only have $10 in my pocket, so I can only buy $10 worth of gas. So I'm going to buy however much gas I can for that $10. So there's lots and lots of reasons that people don't buy the same amount of gas every time they go to the station. So what are the two variables? What are the two things that are changing, and they're both changing at the same time in the same ratio when you buy gas? Well, I hope you said the amount of the gas, and I hope you also said the cost of the gas, because how much you buy changes with how much you put in, and then how much that costs you changes compared to how much you put in. So the two quantities that are changing together are the amount of gas In this case, it was in pints. And in this case, they want us to know how fast it's going. So the amount of gas in the car. Okay, so I paused and drew us a double number line here. So remember, we're talking about the amount of gas that's coming into our tank in pints. And in this particular experience at the gas station, we want to know how fast it's coming in. Not necessarily how much it costs, but how fast we're pumping the gas. So this is the time in seconds. Now, you'll notice that there's two number lines. Both things are changing. The longer we pump, the more gas we put in. So if we only pump our gas for 1 second, I don't know anyone who's going to do that, but if you did, you would get 1 pint of gas because they said up here, it says we fill up our tank 1 pint per second. So if we fill up our tank for 2 seconds, then we have 2 pints of gas. 4 seconds, we have 4 pints of gas. Now they're making it easy on us because the numbers are the same. But check this out. When we get to 8 seconds of filling up our tank, we've put in 8 pints of gas. We're not used to thinking about gas in pints, but 8 pints also equals 1 gallon. So what this says is it takes 8 seconds per gallon to fill up our tank. Every gallon of gas that we buy that we need, it takes 8 seconds to fill it up. Now, that would be kind of a fun thing for you to test next time you're at the gas station with your family. Pull out your phone, watch the tank because the meters will tell you, they go by and say how much gas you're pumping. So when it changes to 1 or when it changes to 2, start timing on your phone or your device. And when it changes to the next gallon, not parts of a gallon, these are all parts of a gallon. But when it changes to the next gallon, see how long that took you. That would be kind of a fun math in our everyday world kind of experience. And if my family and I go out and buy gas sometime during this time, maybe we'll try that too and see if we can take a video of that. That would be kind of cool. Okay, so what variables could we use to represent these two numbers? Well, again, we can choose any variables we want, but I like to choose ones that make sense because they're easier to think about and they make more sense for us. So the amount of gas in pints, what should we call that? What variable should we represent that by? Well, I don't know. How about P for pints of gas? You could name it G for gas. That would be good too. Now, what about time in seconds? What variable should we name that? Well, it makes sense that it would be either T for time or S for seconds. I'm going to go T because S looks so much like a 5. I really try not to use that as a variable if I can, because it's just really hard to tell if someone's writing an S or a 5. So I'm going to write a T instead, but you could call it again anything you want. But I think it's really valuable if the letters you choose make sense with what they're representing. So T makes sense to represent time in seconds. P makes a sense to represent amount of gas in pints. Or G makes a lot of sense. G to represent the gas in pints. Either of those makes a lot of sense. Okay, on the next page, page 255, we start adding in our variables and changing them into a table and using our algebraic reasoning a little more. So I'll put that in a different video. So I will see you next time for part 2.